Hi, I'm Matt, and today I'd like to show you how to embed Rust inside a Ruby program. So Rust is a modern systems programming language that's focused primarily on safety, speed, and concurrency. And it's really nice to throw into Ruby to speed up certain things. So to get rolling, we're going to actually just do nth prime in both Ruby and Rust, and then we'll have benchmarks showing how fast the vanilla Ruby is versus Ruby using Rust's version of nth prime. And we can go ahead and by using cargo, which is kind of like a package manager for Rust, do cargo new embed Rust in Ruby, and this will create the directory that will have everything, the Rust code as well as the Ruby code. So now we've got that, we can cd into that, Rust in Ruby, and we can see there's actually already some stuff in there. So let's go ahead and look a little bit closer at that by opening up Atom. And we can show you kind of how Rust gets the ball rolling, primarily by creating two different files, source, which will contain lib.rs, which has basically this is where all the code will go, as well as, and you can see here that this is like a test for a function. And so what's cool is you can have both the tests as well as the actual code all in the same file, and you can just run the test with cargo test. We won't do that just yet, but let's also check out cargo.toml. And here you can basically see it's kind of like a gem file equivalent if you're coming from Ruby. And we can just see the name, the version of Rust we're using, and the author kind of content, which in this case is me. So we've got that all set up, but let's go ahead and start off just by creating a standard nth prime implementation in Ruby and just throwing that in this same directory. So we've got nth prime here, and because we know we're going to require foreign function interface to bring Rust in, we're just going to go ahead and take care of that now, as well as benchmark, just so we don't have to worry about this later. But let's just start off by creating a module for standard Ruby, and in here we can begin by writing a function, or rather a method in the case of Ruby, to just see if a given number is prime or not. So we'll call this isPrime, and it'll take a num. So within here, we know from the get-go we can just return true if num is equal to 1. Otherwise, we'll set a variable called I equal to 2, and while I is less than num, we can return false if num modulo I is equal to 0, and then we can increment I by 1. Otherwise, we're just going to return true. So this works, but right now it's not actually being used in the context the full context that we need, whereas we're giving the nth prime number that we want. So let's go ahead and write a second method called nth prime. It'll also take a num. And in this case, we're going to say I equals 0 again. Count is also we're going to create and set equal to 0. And we'll line up these equal signs because we're fancy like that. And while count is less than or equal to num, we can go ahead and increment I by 1. And also if count will also be incremented if I is prime. So we've got that all set up, and then in the end, we'll end this while loop, and then we'll explicitly return I. So this should all be working. Let's go ahead and do two birds with one stone by actually doing the benchmark here at the bottom. And so this will confirm that it's working and also get the benchmark aspect up and rolling. So we can just create a number variable and just say like 3000, for instance, and put something so like standard Ruby with an interpolate number in there so we can kind of clearly see what's going on in the terminal when we run this code. And then standard Ruby calling nth prime on number. Cool. And then just a new line to make sure this looks pretty. And now we can run, this code, and it looks like I'm missing an end somewhere. Let's find that. So it looks like just need an end for this is prime method. So hopefully that fixes it. Cool. So we've now got this running. It takes 1.88 seconds. So with this all complete, we can now hop over to lib.rs. And in here, we've got the test working. So we should have done this for the Ruby implementation, but let's do it now for Rust, and we'll write the test first. So all we really need is this, and we can change this name to like fifth prime. Since we know the fifth prime number is 11, we can just write assert equal bang, and that's actually really familiar if you're coming from Ruby. It's very straightforward kind of syntax for testing. And then 11 nth prime, giving it 5, and then adding a semicolon at the end. And so we know this test will fail immediately because there is no nth prime function for it to run with. So we can just do cargo test. It'll compile, and then it'll give us all these errors. So right now it's saying unresolved name nth prime. And that makes sense because we haven't written one. So let's go ahead and follow the same structure as we did in Ruby. First we'll write a function for isPrime, and we'll pass in a number. And this is where it starts to get different. Number one, we can't throw in a question mark, and we also need to be very explicit about what we're giving it. So we just can't give it a random variable named num. We have to be very precise and say it's an unsigned 32-bit integer. We don't have to say unsigned 32-bit. I'm just picking this because for the sake of this demonstration, I know it's going to be a whole number that's only positive. So I'm not going to be throwing a negative number in here. So that's what unsigned stands for. It's a whole positive integer. And then we're also going to be precise about what we're returning by using this arrow. And so we're returning a Boolean value. So Rust now knows exactly what it should accept and exactly what it should return. Within here, it's going to be pretty similar to how we had it before. So we're going to say like, let I equal 2. Then we're going to end it in a semicolon. But we know that the I variable is going to need to go up from 2. So we actually need to be explicit and say it's going to be mutable, which means that it can change later on. So while I is less than num, this is where it's going to get familiar again. If num modulo I, so same as before, is equal to 0, we can go ahead and return false. And then kick up I by 1. And then at the end, just like before, we're going to return true. So this is all good, and now it's just a matter of writing the main, not the main, but the nth prime function that's going to be actually used. So similar to before, we're going to have an unsigned 32-bit integer, except now we're going to return another 32-bit integer. And within here, it's going to be the same mutable structure because we know that I is going to need to change, and then count is also going to need to be mutable. And we're also going to still line up these equal signs. And then while count is less than or equal to num, we're going to go ahead and increment I by 1. And then if I is prime, we're going to go ahead and also increment count by 1. And so that should all be good. We just got to put in the I, and we've got everything here. So this would all be fine. Or actually, let's first run the test, make sure everything is working. Cool, so we got some warnings because there is no main function that this is all being used in right now. So technically, these aren't actually being used in any Rust code, but we can test that they are working the way we expect. And we could even write like a second one just by copying this structure and say something like 500th prime. And we know after a quick Google search, that's 3,571. If we run this test, both should pass. Awesome. So this is all working just fine, but before we can use this inside Ruby, we need to add a few things. So you can see how we're explicitly noting that this is test code. We're going to add something like that to right up here, except we're going to say no mangle. And then in addition to pub extern, which stands for public external, this will allow us to use this code outside of this standard context. So we've got that all set up. Now it's just a matter of updating the cargo.toml. So in here, we're going to want to add lib, and then name equals nth prime, and crate type equals dylib, which stands for dynamic library. So once that's all set up, we've got the no mangle public external in our lib.rs, and we've got cargo toml updated with this information. We can go ahead and cargo build -- release, and that'll create all these files inside target. And the most important one is this one, lib.nthprime.dylib, because that's what we're going to call in our actual Ruby. So let's hop back over to Ruby. And so we'll create a new module called Embedded Rust. And in here, we can go ahead and extend FFI library. And this is where we're going to actually go through this file system over here. And so target, and then down to the release folder, and then specifically lib.nthprime.dylib. And then we're also going to be extra explicit and say the function that we're attaching is nth prime, and then we're taking in an integer and returning an integer in order for it to work. So we've got that all set up. I think it's all set and good to go. It's just now a matter of adding in the benchmark for the embedded Rust version. So we can go ahead and get rid of that. And this should run. So we just run the Ruby. And so we've got the standard Ruby still running, and then we've got Rust running quite a bit faster. And we can even kick up this number to something much larger, like 5,000, and just see how Ruby handles it. So this will take a hot minute, but the Rust should still be relatively quick. So this took 5 seconds, and this still took much less, 0.39. So by all means, not the most elegant way of implementing nth prime, but it's still very cool to see that with Rust, you can take some of the legwork or take some of the burden off Ruby and really speed up some functions. Thanks so much for tuning in, and hopefully this is helpful.